Okay, on this one, we're going to be given information of a particular function that we know is continuous, and we're asked to figure out which graphs could be candidates of that function. So we know the function is continuous. We're on the closed interval from -2 to 3. We know that the first derivative at 0 does not exist. And if it doesn't exist and the function is continuous, it must have a kink there at x equal to 0. So if we're looking at the candidates that they give us, we immediately rule out C because it does not have a kink at C equal to 0. We also rule out D because it's not continuous. So we're right down to a 1/3 chance of just guessing at the right solution of A, B, or E. The next one is f prime of 2 is equal to 0. So that means it must have a relative max or a min there, and it must have a horizontal tangent line at x equal to 2. So we see that in A, we see that in B, we see that in E. Bummer, it didn't eliminate any other prospects. And the next one is the second derivative is less than 0, which means it's concave down everywhere except at x equal to 0. Again, possibly because of that kink. So it's concave down everywhere. This is concave up there, so no A. It's concave down and up, can't be B. Down here, concave down, and inconclusive at x equal to 0 because it's a kink, and we make our selection of E. So what I like about this question is that you immediately, from by looking at one piece of information without understanding the rest of it, we can get down to a pretty good, reasonable, 1/3 chance, and the rest we can look at from just a process of elimination. You could even think of, well, A and B are just really flipping the concavities. E is the only one that's really quintessentially different, and you could guess E logically just from having a third chance and making an argument that A and B are similar, and E is the only one that's different. So I'm going to choose E.